Welcome to part 2 of Competency 1, Practice. In this video, we will work with properties of real numbers. Before we begin, we need to discuss number theory. The first 4 elements are the additive identity, the multiplicative identity, the additive inverse, and the multiplicative inverse. If you're not familiar with these particular items, I recommend that you become familiar. There are a lot of great videos out on the internet that would be extremely helpful. At the end of my videos, there's one particular set of videos on YouTube that I'm very fond of that I think are nice. But it's up to you. There are so many good people out there, right? So if you have to, stop the video, pause it or stop it, and write down these elements or look at them so you can go find a good source. All right, let's move on to the next set. Okay, the next set of items are reflexive, symmetric, transitive, and closure. These ideas are kind of a modern algebra concept, modern algebraic if you took these courses in college. Okay, but they're not difficult to understand. Reflexive is just, A equals A. I know that it seems like a very simple concept, but it can become very complex and complex to prove. Okay, but we don't have to do that. We just need to know that all of these things exist. Like symmetric, we understand when things are symmetric. If one item equals another, then what it equals the one that we began with. Okay, and so just take a look at that. Transitive is a way from there's like a connective. In this situation, B is your connective. So that gives you A is equal to B. Okay, closure, now that's a little different. With closure, this definition is very vague. What closure means, let's say, if you start out with fractions and you only have fractions with whole numbers, let's say fractions with whole numbers, and let's say positive, not even negative. So you have all the fractions that are positive with whole numbers, okay? Like 1/4, 1/5, and so on, or 2/3. All of these. If you apply an operation, you have to end up the value, the resulting value, the answer must also be the same kind of fraction. If it's anything else, then you don't have closure, okay? And it's an invalid operation on those items that were given. So that goes in depth. How far you get depends on the type of question in the situation. Okay, let's move on to the third set of number theory items that we need to discuss. This is a little bit more about closure, a little more detail. So let's look. It says given a set of real numbers are, okay, we're talking about all the real numbers. So if we have A times B and we multiply them and they're still in the real numbers, that will satisfy closure. Because I started with a real number and I'm still in the real numbers. So all's well, and I can say that I have closure and it's satisfied, whatever the conditions are. Okay. So then if I have two real numbers and I add them, and after adding them, they are in the real number still, I come out with a real number for all of the A's and B's, whatever they are, whatever, I'm given, and I still come out in the real numbers, okay, then I still have closure and I'm fine. But let's look at this last situation. It says given a set of integers, and then they say z, because z stands for the integers, we have x times x to the -1 equals x over y, but that's not in the integers. So what they're saying, if you take x, it's a whole number, given as x, it's an integer, It can be negative, it can be positive, but it's a whole number. And I multiply it times 1 over y, which is a fraction. When I multiply those, I no longer have an integer. I have a fraction, which is a real number, but it isn't an integer. It's just a form of real number. And this will not satisfy closure. So this is a situation that you really have to think about and how that works. And of course, it all depends on the question that you're asked in the first place as to what your closure is. If they ask for decimal and they say it has to be a decimal, but when you did calculations, you didn't get a decimal. So you're not satisfying the question or the closure. So either the question is going to be false or your calculations are wrong, one or the other. All right. Okay, now let's go to some actual questions. Number 1, which expression has a value of 15.4? Okay, the best way to do this is to just simply put each of these in the calculator and just simply see which one would end up as 15.4. However, we can kind of look at some of these. Well, I would say it might work because 5 times 3 is 15. So I'm going to leave that one. However, B, I'm not liking B. And that's because I know that this divided by 1/3 actually is the same as saying times 3 over 1. And that would mean 3 times 54 is naturally going to be larger than 15. So I'm going to take out B. We can check it though when we're putting things in the calculator. C, well, I'm going to keep that because if you look at what I said about B, when you look at C, and what we're doing here, by the way, is incorporating those properties that we know. Okay, so if I take that, I'm actually saying times, well, that's 1/4. 0.25 is 1/4. So that would be the same as saying 4 over 1. And 3 times 4 is 12. And then we have to worry about the decimals. So that might get close. So I'm going to keep that. But let's look at D. D says, if you look at the whole numbers, that's the parentheses are multiplying. So 30 times 2 is 60. There is no way. That's not going to work. I'm going to say no way with B, but we'll check it. Okay. That leaves me A and C. Okay. So I'm going to erase this so we can see what we're doing. Okay. Okay. So let's put this in the calculator. So let's put in A, 5.4, and then parentheses, and then second fraction, that gives us our mixed number. 3 arrow over, 2 arrow down, 3 arrow over, close parentheses, push enter, very large. Obviously not acceptable. Okay, but I want to put in B so you can see what it looks like. Okay, so that's 54.12. And that says divide, and then second I don't want that. I just want fractions. Sorry about that. And then that will be divide 1/3. Okay, make sure I put it in because I have stuff written over it. It's 54.12 here. Let me just get rid of that stuff. Better to get rid of it and make sure if my technology will cooperate. Okay, 54, yes, I entered it correctly. And yes, again, like I suspected, it is a very large conclusion. So that isn't going to work. Let's try C, 3.85, and I really hope this works. Division, 0.25. Remember, enter it the way you see it, not the way we know it's equivalent. Okay, push enter. And yes, C is a valid choice. And obviously, D is very large. All right, let's look at number 2. What is the value of the expression 2 to the negative 1 divided by 4. Okay, well, I'm going to arrow down. See what happens when I arrow down? It clears up some space. That's one thing about this particular calculator. It doesn't always automatically arrow down and give us that space we need. Okay, so 2, caret up, negative 1, arrow over. You have to arrow over. You're going to get a mess. Okay, now divide, fraction, and 1, arrow down to 4. Okay, and let's push enter. Yes, our value we need is 2, which is option C. Now I want to show you something equivalent. Okay, I'm going to arrow down. 2 to the negative 1 actually equals 1/2. So I'm going to put in my fraction 1 and my 2. I'm going to arrow over. Now, dividing by 1/4, as I said before, is actually times 4 over 1. So let's do times fraction 4 over 1. Okay, I'm going to push enter. Oops, there. And you see that they are equivalent. They both equal 2. Just a little something I needed to show you. So you can see the equivalence values, and that's also number theory in play. It's all your properties in number theory showing you how it actually works and we use it on a daily basis, and we don't even realize these things. Okay, let's go to number 3. Oops, that has an answer in there, so we actually need to double check. Okay, number 3. What is the value of the expression 3 to the negative 1 times 1/3? Okay, so what do we need to do? I'm going to clear out my screen and clear out my numbers so you can see what I'm doing. Okay, so I do 3, caret up, negative 1, arrow over, but I need my parentheses, fraction 1, arrow down 3, arrow over, close my parentheses, verify that that is what is entered, push enter, and I have 1/9. Wait a second. None of my answers say 1/9. Well, just out of curiosity, I'm going to look at the decimal because look at C. That is a repeating decimal. Remember, that is what? That's one of the properties of a rational number. So push the toggle button above the enter. And lo and behold, I have a repeating decimal, repeating 1. So C is our option. But I also need to tell you about a little thing that happens. When you have a number, let's call that number X, any number over 9, that is going to, see my numerator is just an X. It can be anything. Well, that numerator, whatever it is, if I place it over 9, that becomes a repeating decimal, meaning the actual numerator is the repeating decimal. Okay, play around with that. Let's say take 25 over 9 and also try 25 over 99 and keep playing with values over 9, and you're going to see a pattern occur that is extremely helpful. Okay, number 4. Which expression can be used to find the value of 3/2 divided by 1/8? Okay. All right. So we need our fraction first. Then we have 3 divided by 2, 3/2, and then arrow over, do my division, fraction again, and then 1 over the 8. Verify I entered it correctly, and then push enter. It's 12. Okay, option 12 is it. All right, let's go to number 5. Number 5. The temperature outside is recorded for 6 hours. The temperature dropped 3 degrees each hour for the first 5 hours, and then rose by 2 degrees in the last hour. Which of the following represents the net change in temperature over the 6 hours? Okay, well, the first thing I notice very quickly is that dropping by 3 degrees means minus 3. And then if you do that for the total of 5 of each of the 5 first hours, well, that's going to mean that you have negative a negative drop, a -3, 5 times. Well, that's a negative value. Well, let's look at C and D. C and D do not represent a -3. That's not a drop, that's an increase. So they are not options. So they're out, and that leaves us A and B. Well, they both have -3 times each of the 5 hours. I agree with that. And then when it says rose by 2 in the last hour, well, that would be +2. Well, I agree with that. The only difference in A and B is the result. Okay, so let's put that in the calculator and see what comes out. But also notice they use parentheses. That's not normal notation, but it is acceptable notation. There's no reason not to do what they've done. So let's type it in exactly the way they've done this. Okay, +2. Notice what I've done. Parentheses -3, then parentheses 5 plus the 2, exactly what they did. Push enter. And that is a drop of -13 degrees. So option A is correct. Okay, now let's go to number 6. All right. What is the value of 3 and 1/4 minus 5 and 2/7? Okay, now notice that you got a smaller number that is subtracted. You're subtracting by a larger number. So you're taking a larger amount from a smaller amount. Well, that means our answer has to be negative. Okay, because if you say 3 minus 5, well, that's -2-ish, around 2. So obviously we can eliminate A and D. Well, let's put our expression in and see what happens. So second fraction, that gives us our mixed number, and that's 3, arrow over 1, arrow down 4, arrow over, then minus second fraction, that's 5, arrow over, 2, arrow down 7. Okay, I'm arrowing all the way over so I can make sure that I actually entered it correctly. If you've watched my other videos, I don't always have to fix it when I do it incorrectly. Okay, let's push enter. Ooh, well, that's not a mixed number. Well, not a big deal. Don't panic. Don't think it's wrong. Just turn it into a mixed number and then see what happens. Okay, so what do? I do second, and I need to push the scientific notation button right there. I know it's hard to read. Don't worry about it. That's what you're telling it, the calculator, go from a fraction to a mixed number. So let's push enter. And it does. So option B is what we need. Let's look at number 7. A store has 2 rolls of the same ribbon. One roll has 10 and 7/8 yards of ribbon, and the other roll has 12 and 1/4 yards of ribbon. Okay, so what am I probably going to have to do? I'm saying they're asking, you probably got to add those together. But let's see what happens. The store sells 4 pieces of ribbon, each sold. Each piece sold is 4 and 3/8 yards long. So what am I doing here? I'm going to have to add those 2 rolls together so I know the total. And then I will subtract. I'm sorry. Well, I am subtracting. But before I subtract, I need to multiply 4 times 4 and 3/8. So I take all the ribbon that's in the store and subtract out all the amounts of ribbon that have been sold. Okay, so let's put this in the calculator. Now, what you're going to do is what I have circled. Those items, probably ought to put those in parentheses, okay? So I'm going to arrow down just so you see that, all right? So parentheses, second fraction, 10, arrow over, 7, arrow down, 8, arrow over. Now I'm adding these together. So I push add, then second fraction, 12, arrow over, and I need 1, arrow down 4, arrow over, close my parentheses. Now I'm subtracting another set of parentheses. So parentheses, 4 times, then second fraction, and then 4, arrow over. Notice what happens when I arrow over. It really pushes me where I need to be so I can see what I'm doing. So then 3, arrow down 8, arrow completely over so you can put in your parentheses. Now, you may have been able to enter this differently, but I use parentheses to be safe. Order of operations does come into play, and the calculator cannot read your mind. It only does what you enter. So sometimes using parentheses in combination with other safe things will help. For example, I used my mixed number instead of using division for my fractions. It sets up a solid order of operations. So let's push enter. Well, that's not an option. However, remember what we do. We use the second and that. It's the button we push is actually the scientific notation, but above it is the toggle option. So what we've done is say, I want to go, because that'll get me back and forth, okay? So I'm going to my mixed number, push enter. There we go. Option B is the correct selection. Great. And thank you so much for watching and subscribing and liking and sharing. Everyone who's done that, you guys are amazing. And happy testing, everybody.